So our new notation is going to involve a formula that's on our formula sheet, the number of permutations or arrangements with order. Here's where order matters. We can use the fundamental counting principle to kind of establish this as a good idea or a good rule. I'm looking at graphite, the word graphite, which has no repeated digits in it. And I want to take 3 of those letters. Well, how many choices do I have for the first position? I've got 8 choices for the first position, 7 choices for the second position, and 6 choices for the third position. That's 8 times 7 times 6. And that's what's shown here. That uses the fundamental counting principle. The notation of permutations is defined by the number of elements, so 8 elements, and I'm only taking 3 of them. So I've got 8 factorial divide by 5 factorial, and you see how the factorials actually cancel their way out. Try the factorial button on your calculator. So the factorial button on your calculator is under math. So press the math button. I need to clear where I was at. Math button. I actually need to put in the number 8 first. So 8 math probability, and then number 2, 8p3. So 8p3 is 336, which should be the same as 8 times 7 times 6. 8 times 7 times 6, if I could enter 6, is also 336. So we're going to play around with this notation. We needed to see what 0 factorial was defined as. And 0 factorial is defined as choosing all of the elements. What if you choose all of the elements? Well, by definition, that's n factorial using this p notation. Permutation notation, it would be n factorial divided by n minus n factorial. Well, n minus n is actually 0. And we know that if I have, for example, 6 choices and I'm going to use all of them, it's 6 times 5 times 4 times 3 times 2 times 1, which is equal to 6 factorial. I don't want that 0 factorial to complicate my thinking. The 0 factorial must be equal to 1 to equip ourselves with that same rule from earlier, where if I have n choices and I'm going to use all of them, that it's simply n factorial. So by definition, 0 factorial is defined to have a value of 1. So looking at the fundamental counting principle and license plates, we've done questions like this before. So I'm going to first use the fundamental counting principle. That's nice. The letters I, O, U, or I, O, Y, and Z are not to be used, which means when I look at my letter selection, I'm down to 22 letters for the first position and 21 letters for the second position, because my 26-letter alphabet got reduced. And I need 4 different digits. Apparently nothing with 0 is a problem here. So my digits include 0 to 9, which is a choice of 10, 10, 10, and 10. Oh, except I can't have any repetition. 4 different digits. So how does that go? That goes 10, 9, 8, 7. So if I assume I use my lower one, remember it's 0 to 9, and then 1 to 9, and then 2 to 9, and then 3 to 9. And then I had 22 and 21. So on my calculator, this answer would be 22 times 21 times 10 times 9 times 8 times 7, which is an answer that's really big. 2,328,000, 2,328,480. Well, if I use my permutation idea, well, how does that work? That works by taking my 22 possibilities and I'm choosing 2 of them. And this is an AND situation, so it's times. And then I'm taking my 10 possibilities and I'm choosing 4 of them. So 22p2 times 10p4. That number should be identical to the number we got before. Check that out. Algebraically, we have one equation to solve, and that's this is a fun one. N minus 1 p2. Well, what does that mean? N minus 1 times n times n minus 1 n minus. I have to keep going down from n minus 2, n minus 3, n minus 4. I'm going to stop there. Hopefully I have some canceling happening. In the bottom, remember what that notation means. It means n minus 1, that's the number of choices I have. It means n minus 1, which is the number of choices, and then I'm choosing 2. So n minus 1 minus 2 actually turns into n minus 3. So that's n minus 3 factorial. Sorry, I was trying to get a different color there. N minus 3 factorial. And n minus 3 factorial will actually take out all of those n statements. And I'm left with a binomial. N minus 1 times n minus 2 is equal to 90. And maybe you know 2 numbers that do that. I know I do. 10 times 9 will give me 90. So what does that mean n is? I think that means n is 11. You could also have FOILed it out. So another opportunity is to have FOILed it out like we did previously and get n squared minus 3n plus 6 is equal to 90. N squared minus 3n, subtract 90, so that's minus 82 is equal to 0. Sorry, 84. And you should be able to factor that and generate. Had a 6 somewhere in the wrong spot. Here we go. N squared minus 3n plus 2. Move the 90 over. You should be able to factor that and take the only positive solution into that position. So that's lesson 2. Our calculator is going to come in really handy. Let's try some out.